Yes? We're ready? We're good? Okay. So, first thing we need to do before we do much else, we need to solve for the missing side. We ready? We ready? Yes? We ready? Yes? We're ready? Okay. So, how do we solve for a missing side length and a right triangle? Yes? Perfect. So, we're going to do 4 squared plus the question mark. I'll go ahead and call it x. So 4 squared plus the question mark squared equals 15. And we did this on the other side of the notes, but we did it with what is called a Pythagorean triple, so it like worked out nicely. It was like a whole number answer. And this time it's not going to be nice. So I just want you guys to see what happens in that situation. So we've got 16 equals x squared, plus x squared equals, what's 15 squared, anybody? So minus 16, minus 16. And is 209 a perfect square? It is not. So we are going to say that x equals the square root of 209, and typically when I am the person solving an equation, if I took a square root, I should put a plus minus in front. But in this situation, because I know that my answer is a length, I don't have to put a plus minus because I know the positive answer is the answer I'm going for. Are we comfortable with everything we've done so far? That all makes sense? Okay. So up here, I'm going to write that my side is the square root of 209. Okay. All right. So do you guys want to do theta first or beta first? Beta. Okay. This is beta in Greek letters, beta. So if we look at this right here, the 15 is always the hypotenuse, no matter what. What's the name of the 4? Adjacent. It would be next to the beta, so it's adjacent to beta. Okay, so adjacent. And then what's the name of the root 209? Opposite. All right, so SOH-CAH-TOA, sine of beta would be what? Okay, so opposite over hypotenuse would be root 209 over 15. And if we were in Math 2 right now, we would look at the root 209. We would try to reduce that. But we're not in Math 2, we're in Math 3. And in Math 3, they don't really care. So you could try to reduce it. You could not try to reduce it. In most situations, it won't matter. For the EOC, it especially doesn't matter because you have a calculator for the entire EOC. So on your test, it just really doesn't matter. All right? Okay. When you get into calculus, you can write the answer improper, and they really don't care. So the higher you get in math, the less they care. They just want your answer to be equivalent mathematically. They don't care as much if it's proper or not. Right? So we teach you all that stuff in the lower levels of math so that you understand how to manipulate numbers, and you can do all the manipulation if you had to. But in the upper levels of math, if you're giving an answer for like a free response question, they just go, as long as they got it right, we're fine. Does that make sense? Now, multiple choice is a different story. They would simplify it for a multiple choice. So you still have to have the skill But would they take your answer if you didn't do it? Absolutely, they would. All right. Cos. SOH-CAH-TOA, what would cos be? 4 over 15, it would be adjacent over hypotenuse. 4 over 15, adjacent over hypotenuse. Tan of beta. TOA, tan of beta. It'd be opposite over adjacent, so root 209 over 4. And then once we have the three, like original, the SOH-CAH-TOA ones, what do we do to get the cosecant, the secant, and the cotangent? How do we get the funky ones? Yeah, we flip, flip, flip. So for this one, to get the cosecant, we just do 15 over root 209, and in calculus, say that's fine, but in math 3, we go, it's got to look right. And so how do we fix that to make it look right? Anyone remember from math 2? This is going to be a flashback to math 2. Absolutely. That'd be good. Anyone remember from math 2 how we fix something like that? It's been a minute. You multiply by a fraction. The fraction is equivalent to 1, so the fraction is the same thing on the top and the bottom. It'd be root 209 over root 209. So what we end up with on the top is we have a 15 multiplied by a root 209. Whenever you multiply something that's not under a square root, it just goes in the front. Whenever you multiply things that are underneath square roots, you could multiply them together. So this one does not have a square root. This one does, which means we're not going to multiply those together because it's kind of like they're not like terms, if that makes sense. So this one's going to go in the front, this one's going to stay underneath. So we're going to say 15 root 209. And then for this one, because they're both underneath square roots, we are going to multiply them together. And so instead of actually figuring out what it is, I'm just going to say 209 squared. Are you guys okay with that? 209 squared. 209 times 209 is 209 squared. Okay, so I've got the square root of 209 squared. And what happens if I have the square root of 209 squared? It's just 209. So the square root and the squared cancel, and I just get 15 square root 209 over 209. And even though that answer looks worse than the original answer, it's technically proper. It's called the rationalized answer because it doesn't have a radical on the bottom. So certain mathematicians would say that answer is preferable because there's no radical on the bottom. Yep. Okay, so let's do the answer for secant. What would secant be? 15 over 4. Whew, okay, so that one's pretty easy. 15 over 4. All right, and then what about cotangent? 4 over root 209. And so since this one has a radical on the bottom, we have to multiply it by a fraction. And the fraction that we're going to multiply it by is root 209 over root 209. And the top is going to be, okay, and the bottom's going to be the square root of 209 squared. And what happens on the bottom? Square and the square root cancel, okay. And then 4 root 209 over 209. Perfect. All right, how do we feel about those? The answers look kind of gross for a couple of those, but are we okay with how we got the answers? We can see where they came from. Yes, see some knots? Okay, so now we're going to switch to theta. Theta. Okay, so this is theta. So the hypotenuse is still the hypotenuse. And what is the 4 called now? It is called the opposite side. And what is the root 209 called now? It is called the adjacent side. Okay. So when we switch the reference angle that we're talking about, we switch the names. Not for everything. Not for the hypotenuse, but for the other two sides. Okay, so sine of theta would be what? 4/15, so opposite over hypotenuse. So will be opposite over hypotenuse, okay? Cos of theta would be what? Ca. So ca. Yep. Yeah, root 209 over 15, okay? And then tan of theta would be 4 over root 209. And let's not do the work again because we've already done this work. So 4 over root 209 we did in the previous column. So 4 over root 209 simplifies to this. 4 root 209 over 209. So I'm just going to say I've already done the work there. I don't want to do it twice. Okay. And then we're going to take these and we're going to flip, flip, flip. So sine goes to cosecant. What do we get? 15/4. Okay. Cos goes to secant. So you have 15 over root 209 when you get started. And then Bria was just already doing the simplifying and looking at the final answer. So 15 root 209 over 209. And then for tangent, should we flip this answer, the second answer, or should we flip the first answer? The first one's going to be easier to flip. So you could flip either. You're going to get the right answer no matter what you do. The second one's going to be harder to flip. Well, it's going to be harder to get the right answer once you flip it. So this one's going to be really easy to flip because once you flip it, you get root 209 over 4. And your radical's on top and you are good to go. The other one, you got a radical on bottom. You got to fix it. It's a mess. All right. How are your brains? Good? Good? Okay. All right, we're going to get... So there are 2 practice assignments in here. They're already in the packet stapled together. One is the boring practice, and then one is the zombie practice. Look at the zombie. Brains. And then look, he's sweeping brains and a gerbil. This is brains. Or a hamster. I think it's actually Hammy the hamster. Hammy the hamster, because this particular teacher who publishes her stuff, I've used other worksheets of hers, and he has a name in other worksheets. Okay. Yeah, I didn't make the zombie one. All right, let's look at the boring worksheet first. So this one, it's just having you practice finding one trig value. So it says find the value of the trig function indicated. When it says the value that you're finding, go ahead and circle this, find the value, and write the word ratio. Anyone remember what the word ratio means in math? 2 to 1, yep, what else could it mean? Think rational functions, it means fraction. So for this for the most part is not going to require calculator work. It might for some of them, because some of these, as you can see, they only gave you 2 sides of the triangle, not 3. And you might need the missing side to be able to do the problem. So you might have to do some calculator work. But you don't have to find all 6 trig ratios, you just have to find one. Just the one they asked for, okay? So for the first one, it says cosecant, which means what 2 sides do we need? Yes. Cosecant is the opposite of, yeah, you need the opposite and hypotenuse, okay? So cosecant is the flipped version of sine. So we want the opposite and hypotenuse, and then we want to flip it. Okay, so here's our theta. Which side is the opposite side? 5. Okay, which side is the hypotenuse? 13. Okay, so what would sine of theta be? 5 over 13, and so cosecant is just the opposite of that. It's the flipped version of that. And so the answer for cosecant theta is going to be 13 over 5. That's all you have to do for that problem. 13 over 5. See how I didn't have to use my calculator? I was just making sure that I understand what SOH-CAH-TOA represents, and that I can understand how SOH-CAH-TOA relates to the other 3. So real quick, what I'm going to do is above sine, I'm going to say, oh yeah, cosecant. Above cos, I'm going to say, oh yeah, that's secant. And above TOA, I'm going to say, oh yeah, that's cotangent. I'm just going to remind myself which one goes with which. So cosecant, secant, and cotangent, just so I don't forget. All right, let's pick another one to do that might be intimidating, maybe one that doesn't have 3 sides labeled. 2, so if you look at 2, why would 2 not be as intimidating based on the numbers? They are multiples of 4. Ava, what were you saying? Yeah, number 3 is a weird radical. Number 2, you might be kind of recognizing it, but it's a Pythagorean triple. It's not the common one, but it's a multiple of the common one. So does anyone recognize what Pythagorean triple that is, a multiple of? Can anyone guess what the other side is? 12. So it's a 3, 4, 5 triangle that's been multiplied by 4. Does that make sense? It's a 3, 4, 5 triangle. That's the Pythagorean triple, 3, 4, 5. Except all of the sides have been multiplied by 4. So that's why this one's not too bad, because all the numbers are nice numbers. Does that make sense? So that wouldn't be the hardest one for us to do. Yeah. If you ended up with 5 over 10, I would expect you to write 1/2. 12 over 16, you should reduce. Good question. Okay, so maybe let's try, like, we could do number 3, we could do maybe number 5. Number 5 could be good because we're probably going to have to reduce and we're going to have a square root in there. Do you guys want to do number 5? Okay, so if we look at this one, cotangent is going to require us to have which sides? Opposite and adjacent, and so what sides, well, what's the opposite side? Eleven root 3 is the opposite side, and then what's the adjacent side? The missing side. Okay, so we are going to need the adjacent side for sure. I'm going to go ahead and label that as x, and then how are we going to solve for the adjacent side? We're going to do the Pythagorean theorem, so 11 root 3 squared, yeah. Because this is directly across from it, so it's opposite of it, and then the theta is next to the adjacent. Okay, so 11 root 3 squared plus x squared equals 22 squared. And everyone's good with 11 root 3 squared, typing that in your calculator. We can all do that. No intimidation there. So x squared is 121, and so what does that give us for x? 11. Okay, so if we write this and we go back and do the problem where we're doing cotangent, so it's the flipped version of tangent, so tangent is TOA. We want to do the opposite of TOA. Adjacent over opposite. So cotangent is going to be 11 adjacent over opposite. Okay. So can we leave an answer like this? 11 over 11 root 3. No. Why not? And mathematicians don't like it. For 2 reasons, actually. They don't like the radical on the bottom, and they don't like 11 over 11. Okay, so what should we fix first? Okay, so that's easy. 11 and 11 cancel. So that just leaves us with 1 over root 3. And if we want to fix the radical on the bottom, how do we fix that? Okay, so I'm going to have 1 over root 3, and I'm going to multiply it by a fraction. And that fraction is going to be root 3 on the top and root 3 on the bottom. And then on the top, what are we left with? Yeah, root 3, or 1 times root 3, which is just root 3. And then on the bottom, we've got root 3, the 3 squared. So root of 3 squared. And what's the root of 3 squared? 3. So this right here is the square root of 3 squared, which is just 3. Okay, did I lose anybody, or did we track with that? We got it? Our brains are good. Top is good. Bottom is not okay. I don't know who arbitrarily made up that rule, but they made it up. Yes. Yeah, totally. All right. So 9 is like in your notes, example 3 and 4. So starting at 9, it goes to examples 3 and 4 and asks you to find the missing angle or the missing side. So if you look, they will either have a theta in the problem, and theta is asking you to find an angle measurement. So theta, we'll write this off to the side, theta is find the missing angle. Or x is find the missing side. I'm just writing it off to the side, next to the section that starts with 9. And when we do this in our calculator, we're going to be using the sine, cosine, and tangent buttons. And we never use the other 3 trig functions, secant, cosecant, and cotangent. And the reason we don't use those is because they don't have a button on our calculator, and so we want to do the easy way. We don't want to do the harder ways that don't have buttons. So we just use the first 3. It's not that the second 3 won't do it, it's that we are lazy and we want to do the easy ones. Okay? All right, so first thing we want to do is anytime we are using our calculator and we're going to hit those buttons, if you're going to hit the sine button, the cosine button, or the tangent button, then you have to make sure you're either in radians or degrees, whatever is appropriate to the problem. So when we've dealt with triangles, we have always said triangles are 180 degrees. We've always said degrees with triangles, which means when we deal with triangles, we have to be in degrees in our calculator. So we're going to go to the mode button. And our calculator default is radians, which means our calculator defaults to the wrong mode for these problems. Which means every time you reset your calculator, you're going to have to go back and change it. Okay? So hit the mode button, and you're going to go down, go over to degree, make sure it's blinking on degree, press enter so you're in degrees. And then it should be dark on degree. Is everybody in degree mode? Yes? Okay. All right. So now, what problem shall we do? Just start at the first one? Yeah. Okay. So if this is our theta, the first thing we always want to do with the problem is we want to write the name of the sides. So what's the name of the 5? Opposite. Yep. What's the name of the 12? Hypotenuse. We are only going to label the sides that are there. So once we have the sides that are there, we stop labeling. We don't want to label the blank side because that gets confusing. So based on opposite and hypotenuse, if you think of SOH-CAH-TOA, what side is that? What 2 sides are those? What trig function goes with those? Sine. So now we're going to say sine of theta equals opposite over hypotenuse. And based on the notes last night, if you want to get rid of a sine so you can get the theta or the variable all alone, how do you get rid of sine? You sine inverse it, which is kind of like dividing by sine, but it's not the same thing. It's just the undo, sine undo. So we're going to sine undo the left side. We're going to sine undo the right side. And whenever you hit sine inverse in your calculator is always going to say, okay, sine inverse of what? So we don't do 5/12 times sine inverse. We do sine inverse of 5/12 because your calculator is always going to say, of what number do you want me to do sine inverse? Okay? So sine inverse and sine cancel. We have theta equals sine inverse of the number 5/12. And to do that, you hit, so the button itself is regular sine, so to do the opposite of sine, we do second sine, sine inverse, 5/12. Now, if your answer is a number that makes sense in degrees, like if it's a typical degree measure, it's something between 0 and 180, then your calculator is probably in degrees. If I do the same thing but in radians, my answer is going to be between 0 and 3.14. So your answers are going to be really small every time. So if you're doing a test and you find that every time you do these answers, they're very, very small, and you're like, wow, that's a small degree measure, you're probably just in the wrong mode. See the difference in my answers? So if you're finding that as you do this whole worksheet, your answers are tiny, tiny, tiny for everything, you're just in radians instead of degrees. It's pretty easy to recognize. Okay, so I'm going to say theta is approximately 24.624 degrees, and I'm done. Yeah, yeah. So 10 and 11 are very similar to number 9 because they both have the theta in them. So they're going to be solving for a degree measure as well. Number 12 is different because it has an x. So this is one where you're going to be solving for a side length. It's different from the other side length problems we're solving for because you only have one other side, not two. So we can't do the Pythagorean theorem here. We have to use SOH-CAH-TOA because that's the information that we're given. All right? So here is the angle that we're looking at. If that's the angle that we're looking at, what's the name of the two sides? Hypotenuse and opposite. And so we're using sine again. So this time, instead of saying sine theta, we're going to say sine of 44 degrees because we actually have an angle measurement. So sine of 44 degrees equals opposite over hypotenuse. So opposite over hypotenuse. And there's two situations that can happen here. You can have the situation like this, which is pretty easy, where you have a variable divided by a number. That's really nice when the variable's on top, the number's on the bottom. Because if you want to get the variable alone, what do you do with the number? Just multiply it over. The situation that is a little bit more complicated is when the variable's on the bottom. So we can do one of those too. All right, so I'm going to go ahead and just multiply by 4. Get the number over to the other side so that x is all alone. So I have x is isolated. X is the same as 4 multiplied by sine 44. Here I'm just using the plain sine button. I'm just saying 4 sine 44. That's all I'm typing. 4 sine 44. Should be in degree mode. Because we are working with triangles, and triangles have 180 degrees. That's how you know that you're in degree mode. All right, and what'd you guys get? Yep, 2.779. X is approximately 2.779. Okay. All right, go ahead and flip the page. Okay, let me think about this real fast. There's a lot of sine ones in here. I guess it doesn't really matter. Okay, so let's go ahead and just do number 13 because this is really similar to number 12, but the x is in a different spot. So if we look at number 13, here's our angle. What's the name of our sides? Opposite and hypotenuse again, so we're doing sine again. So opposite and hypotenuse. So we're going to have sine of 30 degrees equals opposite over hypotenuse. And yes, it's technically wrong to not write it, and you'll see why tomorrow, because for this unit we're going to have two ways of measuring angles, and if you don't have the bubble, then it means you're doing the other one. And so you should always write the bubble if you're in degrees. Am I going to mark you down for it when it's in the middle of a problem and your final answer is not in degrees? No, I'm not going to mark you down for it. But as far as mathematical practice goes, you really should always put it. Yeah. All right, so anytime you see the variable on the bottom, I see a lot of students solve these incorrectly, especially in Math 3 when they first learn how to do, or Math 2 technically is when you probably first learned how to do this. So students typically when they're first learning this get them wrong a lot, and then later they start to get them right. So the easiest way to solve these if you're going to have a tendency to have a hard time with the variable on the bottom is to just put the other side over 1. And then to cross multiply, because you guys are typically really good at cross multiplying. So once you put it over 1, then you can just do 1 multiplied by 3 is 3, and x multiplied by sine 30 is x times sine 30. And then go from there. So that's a lot easier for students to deal with. Any questions about that? Does that make sense? So when you have a variable on the bottom, just make the other side a fraction, put it over 1, and cross multiply. Easiest to handle. Okay, so at this point, how do we get the x alone? Okay, so divide both sides by sine 30. And what did you guys get? Just 6. Oh, not even approximately, just plain 6. Okay. Perfect. So for the assignment today, you're going to do the boring stuff. And then the way that this worksheet is set up is so that the answers that have the hamster wheel next to them are the ones that are going to correspond to the answers at the bottom of the page. So not every underlined answer has a matching answer at the bottom of the page. It's only the ones with the hamster wheel. Does that make sense? And I believe that a couple of them are like slightly off, but I don't remember if it's on the front of the page or the back. I think it might be the back of the page. So the front of the page is regular credit. The back of the page is extra credit because it's a little bit overkill and I'm not going to make you guys do it. So at the top of the back page, write extra credit. You do not have to color the zombie if you don't want to. You are welcome to do so. So if you are interested in doing the extra credit, let me know. I will post, actually I'll put this up on Canvas. I'll put some hint numbers. I'll write some extra numbers in here because they tell you to round answers, and it's using rounded math in the middle of a problem is so very weird. Anyway, I know from experience that this back page is a little bit overkill, so I'll put some numbers in here to make things easier so you can kind of make sure that you're like getting the right answers as you go, just to make that page less frustrating. All right, but I'm pretty sure the back page, the answers don't match up perfectly. So do the boring practice and then do the front side of the page. Any questions? Nope. All right, go ahead and get started.